All right, and lastly, together for Module 11, we are going to do numbers 9 and 10 of the extra practice problems. So number 9 says, if you want to lower water's freezing point 5.00 degrees Celsius by adding CaCl2, what must be the molality of the salt solution? Remember, when they're talking about a salt solution, a salt can just refer to an ionic compound. So we're just talking about the CaCl2 dissolved in the water. That's the salt solution. Okay, so for this one, we are looking for the molality. And what we know is I remember, is how many ions CaCl2 will split into. So we will end up with 1 Ca ion and 2 chlorine ions. So that's a total of 3. So I equals 3. Okay, we know Kf because that's a constant given to us at the top of the page. And we know that we want to lower the freezing point by 5 degrees. So the delta T would be negative because it's going to be lowered. So negative 5.00 degrees Celsius. All right, so looking at all this stuff, we can see that the equation that we're going to want to use is delta T equals negative I times Kf times little m for molality. And we are going to rearrange this and divide both sides by negative I times the Kf value to solve for molality. So once we rearrange this, it looks like m equals delta T divided by negative I times Kf. And that's how we'll solve for molality. So now we just have to plug the numbers in. So the delta T equaled negative 5.00 degrees Celsius. And then we're going to divide that by negative 3 for the I value. And the Kf value for water is 1.86 degrees Celsius per molality. So you put this into your calculator, okay? And you would end up with, let's see, I gotta get myself caught up here. Okay, 0.896 molality. That would need to be the molality of the calcium chloride and water solution. So that's how you do number 9. And lastly, number 10 is a boiling point elevation problem. Number 10 says, what is the boiling point of a solution made by mixing 100 grams of NH4(2)S with 750 grams of water? All right, so we are looking for the boiling point. And what we know is, let's see, do we know I? Well, we can figure it out, can't we? We have NH4(2)S. So this is going to split into 2 ammonium ions and 1 sulfur ion. So that'd be I equals 3. The Kb, we know, is given to us at the top of the page. It's 0.512 degrees Celsius per molality. And then we would be able to figure out the molality of the solution. So let's figure that out right now. Molality equals moles in this problem of NH4(2)S divided by kilograms of H2O. Okay, we don't have the moles yet, but we do have the grams for NH4(2)S. We have 100.0 grams of NH4(2)S. So if we multiply that with 1 mole of NH4(2)S on the top, and then the number of grams of NH4(2)S on the bottom, and in 1 mole of NH4(2)S, there are 68.2 grams. Of course, I found that from looking at the periodic table. So 100.0 divided by 68.2 equals 1.47 moles of NH4(2)S. Now we can figure out molality. Molality then would equal 1.47 moles divided by how many kilograms of water? It would be 0.7500 kilograms of water. So molality would equal 1.96, little m. And now we're ready to plug everything into our boiling point elevation equation, which is delta T equals I times KB times M. So I is 3, KB is 0.512 degrees Celsius per molality, and the molality of this solution we figured out is 1.96. So if you multiply all those things together, you would get a delta T of 3.01 degrees Celsius. Now, is that the answer? Were we looking for how much the temperature would change? No, we're looking for the actual boiling point. So the boiling point of water is normally 100 degrees. So we have to add 3.01 degrees to 100 degrees. I'm just going to put this on the board to show you significant figures. So 100.0 degrees Celsius is what our book has told us to memorize as the boiling point of water. So we go to the 10th, what's the word? The 10th column or whatever. I can't think of the math term, I'm sorry. 100.0, and then we're adding 3.01 degrees Celsius. For significant figures, you can only go to the place value. That's the word I was looking for. You can only go to the least precise place value. So that would be the 10th column. So if you add this, you would get, I'll just put a big equal sign here, 103.0 degrees Celsius would be the new boiling point. And that is how you would do number 10. Now, if my students have any questions, you know how to get a hold of me before you take your Module 11 test, so please reach out if you need to. Thank you, and happy chemistry problem solving. Bye.